Hey everyone, Mr. Smith here. In this video today we're going to be talking about graphing the third form of a quadratic equation that we're going to be looking at, and it is called standard form. So just as a quick recap, we have looked at two types of quadratic equations. We've looked at this, which is known as standard form, and we have looked at this type of quadratic equation, which is known as intercept form. Or maybe you've heard it called factored form, but those are the two types that we've looked at thus far. In this video, we're going to look at when a quadratic equation looks like this: y equals a times x minus h squared plus k. When a quadratic equation is written like that, it is written in what we call vertex form. Okay, and I'll explain why it's called vertex form here in a second. A couple quick things about this type of quadratic equation. The graph opens up when the a value, or the front value, is positive. So notice how that's the same. That trick always works no matter what form of quadratic you're working with. The leading coefficient, the sign of the leading coefficient will always tell you if your parabola opens up or down. So if it's positive, it opens up. The graph opens down. The parabola opens down when the a value is negative. So that is always the case. We can always use that little trick. Okay, here's why this thing's called vertex form. It has to do with the h and the k. Turns out that the vertex of this parabola is really, really easy to find when we're in vertex form. All we have to do is look at h and k. It's the h is the x value of the vertex, k is the y value of the vertex. There's one trick that we have to deal with here. So I just said that h is the x coordinate of the vertex. That's also the axis of symmetry, if you remember. Remember, if I have a parabola, here's my vertex, here's my axis of symmetry. The x coordinate of the vertex is also the same value of the axis of symmetry, okay? So h tells us the axis of symmetry. That's also the x coordinate of the vertex. And here's the trick that we kind of have to deal with here. A little thing we have to keep in mind. I have to flip the sign of this value when I take it to mean the axis of symmetry. So I have to flip the sign. And the reason for that is that in this equation, this is written as a negative. So I have to consider it as like an opposite. Okay, so I'll show you an example of that here in a minute. The k value is the y coordinate of the vertex. So this tells us the y coordinate of the vertex. And I do not need to flip the sign of the k value because it's just written as positive. I can just take it for what it is. Okay, so let me give you an example of all these things. This is probably the easiest form of quadratic equation to work with because the vertex is so easy to find. So I'm going to look at example A right here, and that'll wrap it up for this video. We'll just go through. We're always going to make a table. It's asking me if I have a maximum or minimum, what the axis of symmetry is, what the vertex is. Okay, so let's think about maximum or minimum. So remember, that depends on how the parabola opens, whether or not it opens up or down. To determine whether or not it opens up or down, all I have to do is look at the leading coefficient, which in this case is a -2. I'm going to have to ask myself, is it positive or negative? If it's positive, remember, if it's positive, it opens up, and if it's negative, it opens down. Well, this is clearly negative, so that means my parabola looks like this. It's opening down, okay? It's like a frowny face. So my vertex is up here. Clearly, that is a maximum value. That's like the top of a mountain. Okay, so I know I have a maximum value just by the nature of knowing that my parabola opens down. I can see that there will be a maximum value there. Okay, remember, if your equation does not have a visible number there, so let's say this equation just looked like this. And I don't have that -2 there. Remember, there's an imaginary 1 right there that we just understand to be there, even though we don't write it. So I would say that there's a 1 in front of that, and it's positive. Okay, so just keep that in mind. This one has a -2 though, which is pretty easy to work with. So I got a maximum value. Let's think about the axis of symmetry. Remember, that is this number inside of the parentheses. It's the h value, the number that's with the x. So all I have to do to find the axis of symmetry, which is also the x-coordinate of the vertex, is just look at this number inside the parentheses and flip the sign. So I'm looking at this number. It's a +2. I'm going to change that sign and say, hey, I know the axis of symmetry without really even doing anything is -2. Okay. Turns out that's also the x-coordinate of the vertex. So the vertex is the point -2, and then to find the y-coordinate, all I have to do is look at this, and I don't have to change that sign. So the vertex is -2, 3. That's pretty easy. Way easier to find the vertex in vertex form than any of the other forms of a quadratic that we've looked at. All right, so now we have everything we need to graph. Remember, once I have my vertex, I put that right in the middle of my table, and I'm going to build everything up from there. So I'll do 2 points that are bigger, 2 points that are smaller, and just like in standard form, I'm just going to take these values and plug them into the equation to see what I get. So let's plug in -1. I'm actually going to make a new page here to do that. So my equation, y equals -2 times x plus 2 squared plus 3. Y equals -2 times x plus 2 squared plus 3. So here's my equation, and I'm going to plug in -1 and 0. Okay. Remember, once I get half, I can just copy these y values down here because the parabola is symmetric. And I'm going to choose these x values to plug in because they look like they're going to be easier to deal with than these ones. Okay, so you can kind of be strategic in how you go about doing this. So let's plug in -1. So it's going to be, I'm taking this value and plugging it in for x. Y equals -2 times -1 plus 2 squared plus 3. Okay, we got to be careful here that we follow our orders of operations. So we got to remember our orders of operations. PEMDAS, please excuse my dear Aunt Sally, or whatever other acronym you've learned for it. Parentheses, exponents, multiplication, division, addition, subtraction. I see parentheses, so I know that I have to do those first. All right, so it's going to be -2, -1 plus 2. That's just +1 squared plus 3. So I did the parentheses. Now I move to exponents. 1 squared is 1 times 1, which is just 1. So I have -2 times 1 plus 3. And now I can solve this out pretty easily. -2 times 1 is -2 plus 3. And -2 plus 3 is 1. Okay, so I know that when I plug in -1 for x, I get 1. I get 1 for y. All right, so now let's plug in 0. Again, I'm just taking that 0 value and plugging it in for x. So it'll be y equals -2. Y equals -2 times 0 plus 2 squared plus 3. Again, parentheses first. 0 plus 2 is 2. So I have -2 times 2 squared plus 3. Then I move to exponents. 2 squared, that's 2 times 2, which is 4. So I have -2 times 4 plus 3. And now I can just multiply and add. So -2 times 4, that's -8 plus 3. -8 plus 3 is -5. Okay? So when I plug in 0, I get -5 for my y value. So I'm going to go back to my table. When I plug in 0, I get -5. And now that I have 1/2 around the vertex, since the parabola is symmetric, I can just take these y values, flip them down here. I don't even have to plug those guys in. I know that that's going to be the case because the parabola is symmetric. So now I've got everything I need to graph this. All right, I'm just going to go plot these points. Let's go plot the vertex first. We'll do the vertex in blue. Change up the color. So the vertex is -2, 3. So I go back 2, up 3. There's my vertex. Okay. Now let's go ahead and plot all of my other points. -1, 1, back 1, up 1, 0, negative 5, I'm at 0 and I go down 5, negative 3, 1, I go back 3 and up 1, negative 4, negative 5, I go back 4, down 5. All right, so I got my points, and now I'm just going to draw in a parabola. And that is my graph, okay? So hopefully this example is clear. Big things to remember for vertex form, you need to flip this sign. That is the big deal with vertex form. To find the axis of symmetry or the x-coordinate of the vertex, those are the same thing. You have to flip that sign, okay? If you don't flip that sign, everything's going to be messed up from there, okay? So we need to flip the sign, put the vertex in the middle of our table, and build it out from there. All right, and then we can determine if it's a max or min just by thinking about which way it opens, and we determine that by looking at the sign of the leading coefficient. Positive means going up, negative means going down. Okay, if you guys have questions, please let me know. We'll see you soon.